So first we will understand the basic thing about this MRI segmentation or MRI brain tumor segmentation. So first we will see the introduction part. We will see machine learning, deep learning, neural network, convolution neural network. Then after that, how we can segment those brain tumor part. So first we have to detect it, then we have to segment it, and then we will find the conclusion and future scope for the research. So this is the basic framework for any machine learning model. This is a traditional one. First, we will take the input image, then we use pre-processing. So right here, what we will do after importing the data, we have seen the information and we have find out that there are different images with different values, those values which contain zero, null value. So we have to remove those null values. So after cleaning your data, you need to process those images for feature extraction. Then we use classification. And after that, we perform post-processing. So this is a basic model for AI, machine learning, or deep learning. Generally, everything related to machine learning, deep learning will come under the artificial intelligence. Artificial intelligence is a bigger domain. And machine learning and deep learning are the subdomain, or we can say subpart of this artificial intelligence. So nowadays, most of the research work is going on in the deep learning. So there are different type of machine learning algorithm which we can apply. You can use supervised learning, unsupervised learning, or reinforcement learning. Generally, supervised learning is that learning where we have the image and what is contained in that particular image, the label is also defined inside the supervised learning. Whereas in unsupervised learning, we don't know the label. What we have to do, we have to cluster all the images and find out the solution or find out the particular group for that particular image which you are using. Okay. In reinforcement learning, we are using reward and penalty based technique over there. So there are different algorithms for supervised learning. Like you can see in classification, you can use logistic regression, k-nearest neighbor, sport vector machine, kernel SVM, naive Bayes, decision tree, random forest, evaluation classification, and model performance. Whereas in regression, you can use simple linear regression, multiple linear regression, polynomial regression, sport vector regression, decision tree, random forest, and there are different model performance and regulation of these models are also available in supervised learning. Whereas in unsupervised learning, we are using clustering. And for clustering, we are using two algorithms right here, k-mean clustering and hierarchical clustering. Whereas for dimension reduction, we are using PCA, principal component analysis, or LDA, and kernel principal component analysis we are using right here. And for unsupervised learning, we are using association. Whereas in random forest, we are using action reward with upper confidence bond. So these are the different type of machine learning algorithm which we can apply for our data. So this is a basic block diagram right here. What we will do in machine learning, first we train the model. So right here you can see, first we will take the input of the image, then we extract the feature, and then we put all the value to the classifier. In real time, when you give all the data, it will check and it will find out the correct label of that particular image is available or not. Whereas in case of deep learning, this feature selection part is automatic. You will take any image, you can use convolution, multiple convolution layer. As you can see right here, there are multiple convolution layer. After that, you are using pooling operation, and then you are using flattening operation. Then fully connected layers are there, and finally you get the final decision. So there are different machine learning tools are available. You can use Cafe, CUDA, ConvolutionNet, Theano, Tor7, MATLAB. You can also use, and TensorFlow. So generally, TensorFlow is used to used for this end-to-end open source platform for machine learning. And we are using, we will take the input layer, then inside this input layer, multiple hidden layers are there. Then we will find out the final decision that is present inside this output layer. So how this process is going on? Let's suppose that this is one image. Okay, this is one image. And first step is we have to define the kernel. Right here, I am taking this kernel as 3 cross 3. And I am defining these xk values for the image. So what we have to do, we have to multiply wk with xk. Okay. So each value of this wk will be multiplied with this xk, and the maximum value or average value you have to select from this particular filter. So whatever the filter size you will take, that much value will be you will be getting in the final output. Okay. So right here, I am using one filter. So this one filter is multiplied. Wk will be multiplied with the xk value, and it will give me the first output. Then I am using stride. Stride means how much value it will take after one stride and two stride. If I am taking one stride, so this particular filter will move 1 pixel from this side, left side. So it will left the first row, first column, and it will move toward the next column. Okay, so one stride means we have to left first pixel from left side. Okay, so then you will see in this particular figure, our filter is placed over this particular region. Now we have to perform again the same operation. Wk will be multiplied by the xk, and we have to find out the average value or maximum value from this particular matrix, and we have to place that value right here. Okay, so you can see right here, this type of stride operation we have to perform first step. In the first step, then we have to use the padding. If let's suppose that this filter is moving away from this existing image, so what we have to do, we have to place the 0 value in as an initial. Okay, so right here, if size of this filter is not matching to the image, you have to pad with the 0. Okay, so then your filter will move toward the image, and you will get the final output. In the pooling operation, what you will do, after multiplication, you will see right here, we are using max pooling operation. So whatever the maximum value we are getting, we are placing that maximum value right here. Whereas in case of average pooling, we have to take the average of this particular 2 by 2 matrix, and we will get this average pooling operation. We have taken 2 type of images. One image is post, and second one is authentic. And both these 2 type of images we are going to give to the convolution neural network, and that convolution neural network will train these 2 type of images for long, for about 40 to 50 hours of training session. Then we will get the trained model right here. After that, what we have done, we have taken different images from different data set. Then we use transfer learning operation. And again, we have trained this model with the different images. Then we classified in 3 types, what type of images and what type of forgeries. So these type of forgery we have extracted first. After that, we have created this data for the segmentation. So in which part of the image forgery is present, again, we have passed this model, trained model into the convolution neural network. And with the help of semantic segmentation, we extracted all the images. So this is one example I am explaining right here. This is the second one where we have created 91 layer deep convolution neural network. This paper is also published. We have used deep convolution neural network, and with the help of this, we extracted the force portion exactly, and all the force portions are highlighted with segmented region. So same operation we can apply right here for the MRI tumor detection also. So how this will work? First, we take any image, then we will perform multiple convolution operation, then we will get the scores, and after that, we have to get the final segmentation of that particular image. How this process will be performed, we have to see right here. For this classification, we are using this binary classification neural network right here. First, we will take the input of the images, and we process these inputs. Okay, and in the final output stage, we will get a one output neuron right here. So it will give us binary result. Either that result is in 1 or that result in 0. So number of neuron in output layer is 1 in binary classification. And right here, we are using sigmoid function. So you need to understand these things first. Then you will create a neural network. So how much input layer you have to take, how much hidden layer you have to take, how much output layer you have to take. If you are performing classification operation that is in binary, then one output neuron should be present. And in the output, you have to use sigmoid activation function. And you can also use ReLU and leaky ReLU as an activation. Okay. Whereas in multi-class classification, you can see in the output, whatever the classes you are using. In CFAR, you have seen, CFAR is the most commonly used example where you have to take the 10 numerical values starting from 0 to 9. So in the output, you have to predict what value you are inputting. When you give 1, automatically it will show you in the output as 1. So 10 classes are there. So we are using over there, whatever the classes you are going to define in the output, you have to take that much number of neuron in the output. Whereas in the output, we are using softmax because every value which you are getting in the output, that will be in a regression mode. Okay. And input and hidden layer we are using right here. And with that, we are using ReLU and leaky ReLU as a activation. So right here, most commonly used activation function is ADAM. So mostly we are using ADAM optimizer. You can also use other optimizer function also. So SGD is there, AdaGrad is there. And for that, we are removing some losses which is present inside the image. For that, we are using binary cross entropy and categorical cross entropy. So you can see right here, we are using this sigmoid function. So inside this sigmoidal function, we place any value. So whatever the value you place right here, that will give you the final output. So this gives the probability of that particular class. And you need to put that probability right here and find out the final equation of this particular model which you are using. Okay. So this is a leaky ReLU and a ReLU operation right here. In ReLU, you are taking value in this manner. Whatever the value you will take at this 0 level, that is to be considered as 0. When you are in your function is increasing, So you will consider that value. Okay. So all these values starting from this particular point to this point, that will be placed in 1. Whereas in leaky reload, you can see right here, if the value is below the particular threshold level 0, then also you can select that particular value. With the help of UNet, first we have to downgrade our images. We will take the higher resolution image in the start. So right here, you can see 512 by 512 image you will take in the first step. And in this, you will find a layer, particular image with a convolution 1x1. And then we have to increase the size of this image. Okay. The network architecture. Firstly, we will use this convolution path for the encoder. We will take the image of 512 by 512 and we will get a final size of 1024 right here. Then we will use up-pooling. Okay. In the up-pooling, again, you have to increase the size of this image to the level which you have defined initially. So it will take multiple steps of convolution, ReLU, and max pooling operation. So generally, this semantic segmentation algorithm will overcome the vanishing grading problem and overcome the overfitting problem. So what does these mean, overfitting and vanishing grading? So vanishing gradient means when you have multiple local and global minima. So if you take the learning step very small, then your model will learn, but not reach up to the particular level. Okay. So if you take a larger step, then your model will learn very fast and it will stuck in a local minimum. So you have to tune the learning rate of your model in such a manner that this vanishing gradient will be overcome. So this UNet is used in this case. What we will do, we will apply the input to the layer and we will train the model. If some value is not getting according to the final result, you will pass the value to the next level and added that value to the next level. So this is the particular pyramid model right here, where we have to up pool or down pool the particular image, and we will get the final output. Generally, we will perform this using RCNN. Okay. And you can also use simple neural network, but that will bottleneck your final segmentation output. So this is the upsampling process which we have to perform right here. And then we have to perform these operations for upsampling. Okay. So this is the mathematical expression right here, in which we have to take the input image, multiply the filter with this image, and get the final value. And you will find all these steps for the furthest operations and get the final feature map for the output. Right here, we have a 2x2 matrix that is multiplied with this 2x2 feature map. When you multiply this feature map with first pixel value, you will get all 0. Then we are using one stride. So when you move to the next value, the second 2x2 matrix will be filled with the second pixel, that is 1. And 1 is multiplied with the filter. So this is a filter. You will multiply all the values with this filter. Then we will use again the stride of 1. Your next, this filter will move to the bottom 2x2 matrix right here. So you will see right here, 2 will be multiplied with all the values and you will get this value right here. After that, Last one is 3. So 3 will be multiplied with this filter value and you will get the final result right here. So we have to add all these values and get the final output feature map. So in this manner, we have to segment all the pixels. So let's see what we are doing right here. Firstly, we have to import different library. I have told you, you have to import Panda, NumPy, Seaborn, and Matplot first. So generally, Panda is used for the file handling. So whenever you want to import some files, you have to use Panda. NumPy is to be used for manipulation of the data. That is, if you want to perform mathematical operation, then you have to use NumPy. Seaborn is used for a graphical representation of your data in interactive way. Whereas this matplot will be used for the plotting purpose. And you want to plot bar chart, pie chart, line graph, you have to use it. CV2 will be used for image manipulation part. Okay. So whenever you want to deal with images, you have to use CV2. CV2 is present inside the OpenCV. SK image, you have to use for the images, IPython for display, operating system for system time and date, random for importing data in a random way, then you have to use glow for the variable. Firstly, what we will do, we have seen the basic model for machine learning. Okay, you have seen already right here. In the machine learning, what is our first step? We have to take the input image, then we have to use pre-processing. So this step we need to perform right here. So firstly, what we will do, we are taking the image from the given path. So I have defined the path of this particular data set, which is present under C drive. So just if you want to say this, you can say this data is present inside C drive, download image and MRI. This data is present right here. This is a CSV file. Okay. So you have to read it. How you will read it? You have to use a function. What is the function name? Read underscore CSV. So this read underscore CSV function will read the data from the given location into the variable that is brain underscore DF. So what is this PD? PD is a alias. Alias means it is a short form of this pandas. Okay, so whenever you want to call this panda library, you have to give nickname to it. The nickname is PD. That is called alias. Okay, so we are importing the data right here inside this variable. And if you want to see the information of this particular data, you have to use the function info. With the help of this info function, you can find out what type of data you have inside this particular variable. So firstly, we have to give the variable name. The variable name is brain underscore DF. And then we have to call the function. So what is the function name? Info is the function name. Okay. So right here, you can see the columns. How many columns are there? There are 0 to 17 columns are there. And how many null values are present? You can see these are the null values, non-null values are present right here. And what are the different data type for these values? You can see right here. Okay. After this, what we have to do, we have to select the particular image which we need. Okay. So let's see first what is present inside this particular folder and what image we need to extract it. Okay, from this particular folder. So you can see when you double click on this. Okay, so you will see these type of images right here. So all these images which you are able to see right here, these are the brain tumor images. Okay, so first we need to create the segmentation of these images. Okay. First, understand this data. This is the segmentation part. Okay. So we have created the segmentation already. Okay. So segmentation means we have created the patch here, the tumor is available. So this data you need to prepare first. So 80% of your work is for data preparation. Okay. After that, you just need to train your data and get the final output. So this is your data right here. You can see what is present inside these images. First image is, you can say this is a HT image, and second one is a mask. Okay. So this is brain tumor image. And second one is the mask for this image. Okay. So you can see right here, this is the brain tumor image. And second one is the mask for this image. If some tumor is present inside the brain, then you will find this particular mask right here. If there is no tumor is there, then this image is black only. Okay, so you can see right here, there is no tumor in this image. That's why this image is black. Okay, so you will find first image, and then you will find its segment as a tumor. You will see right here. This is the first image. Okay, see this image. Right here, you will see something. Okay, so you need to consult with doctor and find out this particular portion is containing what type of problem. Okay, so this mask is created by the expert. Okay, we have not created this mask. So this mask is created by the doctors, those who know what is brain tumor. And with the consulting of doctor, they have created this mask. So we have to prepare our data like this. Okay, so similar task we need to perform in this particular command. What we have to do right here, we have to use the files which are present right here, Okay, so what we are using right here, we are using subdirectory, and we are splitting this from -1 to 17 index, okay, till the last index. Then we are defining this into the directory, and we are getting the file name, and we are using the exception right here. Why we are using this exception? Because there are other files are also present inside this folder. When you see right here, these folders are subdirectories are present, but these two files are also present right here. Okay, so if you will not give exception to this particular program, then it will not give you the correct result. Okay, or it will give you the error. So that's why we have placed the exception. We are excluding these two files, and you will see the path of these two files right here, data.csv and readme. Okay, readme.md5. In the next step, we are creating the map for the images, and we are showing the map right here with the index 0. And after that, we are extracting the patient ID. So you will see, I will take the first image inside this I, and inside this list, I will take the first to the last value, and we are placing inside this loop. And what value I am taking? I am taking the second value from the index. Okay, so which value I will take for the patient ID, you will see the data right here. Okay, you will see the data. When you click on this first image you have to take, then you have to left this mask image, then you have to select this next image. So index number, this first index is 0, this index is 1, and this index is 2. You have to select this first index as 0 and next index is this one. Okay, so you will select this index, last index as 2, and then you will place the data inside this data frame, that is DF. If you want to see the output of this head, you can find out what are the top 5 values inside it. Okay, and you can see the path of this particular file right here. So all the files which are present inside it, I have shown only one file for index number 3. So you will see this index number 3 file is TIFF file. Okay, so TIFF is an extension for this medical image. Okay, and now after that, we have to define this particular data with the length, how much length is present for this data. So right here, you can see the base length of this data is 96. So for this, we have to import the data. Okay, so what we are using right here, we have used the package name random. So with the random function, we are importing all the values. So first, we have to read those images which are not containing any mask. Read the image path from the data frame with which does not contain the mask image. So you will see right here inside the folder, this first image is your brain tumor image. This second image is the mask. So we need to extract this image and this image. We will not include this particular image. So what we have done right here, we have used this mask option right here. This mask is a label right here. So if this mask is present inside the label, okay, if this mask is not present inside this label, then all the images where this mask is not present, those images will be stored inside this particular variable. If mask is present in the label, then all the images will be present inside this particular variable. You will see right here. So this is the image. Okay. So right here, you can check this one. Okay, this is the image. Right here, you can see what is the label. Label is mask. Image name is right here, mask. Okay, so we are extracting mask images and not mask images. So when you will give not mask, this image will be extracted. When you give mask, then this type of image will be extracted. Okay, so we have separated both the images. First image is a non-mask image, that is a brain tumor image. Second one is the mask image, which contains the tumor. Okay. Now, what we have to do after that, we have to sort those images, okay, according to their key values, and we have to give all the values according to their particular sorting order. Okay, so right here we are defining this particular path with the value, and we are defining the base length. We already extracted this base length to 96. So how much length of this particular path is available? You can say this complete length is 96 for this. So you will say this is the data. Okay, if you count all these folders right here, okay, so all these folder will contain, okay, different images. So you have to select particular folder from it. So that's why we have given the length of this base length to 96. And what is the end length? We have to select from this. You have to take it. Okay, so right here, all the images with the tips that will contain only this end image length to 4. So how this end image length to 4? You have to count these 4 letters. Okay, dot TIF. All these 4 letters will contain a length of 4. If you count all these characters right here, these characters are in 9 in numbers. Okay, so that's why end length is 9. So you have to select this length and select all the values for the image and the mask. So now your data is ready. You have selected the images, you have selected the mask. Now you have to perform different operations on these images. Okay, so first we are importing right here CV2 to work on the images. So we are using this data frame. So what we are extracting from this data frame? We are extracting the patient ID, image path, and the mask path. Only three things we need to perform this task. So first, we need the images which contain the tumor and the images which contain the mask of that particular tumor. Okay, and then we need the patient ID. So in the next step, what we are doing right here, we are labeling the mask images with 1. Okay, so right here, we are defining the value for this. So with the help of CB2, we are reading the images with the mask path, and we are defining these values to this. Okay, and you will see all the values with the patient ID, image path, and the mask path will be defined these levels. So you can see mask path with a level of 0. Okay, you will see the next image with a label of 1. So whatever the image you are taking, if that image contain some tumor part, that is 1. Okay, non-tumor part is 0. Okay, so we have given the categories. We are performing right here supervised learning. So we are training our data with the labels 1 and 0. So 0 stand for no tumor and 1 stand for the tumor. So you will see this file right here. We are using CV2 to read the image. Okay, and from where we are reading this image, we are using this brain underscore df. This is a variable. From this particular variable, we are using the function name mask underscore path, and we are giving the index number 2. Okay, so whatever the path is available from this index number 2, you will get this data. Okay, so index in Python, indexing start from 0. So 0, 1, 2. So whatever the third image is available, that will be shown right here. So you will see this image right here. This image will contain the tumor portion inside your brain tumor image. Okay, so now we have to show the other image with the segmentation part. Okay, so again, we are using CV2. I am reading this file from this brain underscore df variable with the help of image underscore path and giving the index as 2. And you will see this matplotlib will plot this particular graph into this in the color form. Okay, so right here we have to display the taller mask images. So this is nothing but we are taking this PLT for plotting, and we are subplotting all the images right here. We are taking 5x3 matrix for plotting, and we are giving the figure size 20 by 30 pixel. 20 is the length and 50 is the width. Okay, so we are defining the range function, and from this range function, we are passing the brain underscore df. Now you will see right here, we are defining this variable right here, whatever the length of this brain underscore df, the size of this data set, all the images will get into this particular range. Okay, and then we are defining the mask and non-mask images, and you will see right here, first image, and then the mask image, and then the segmentation image. Okay, so these images are combined and shown right here. You can see right here, all the images are combined together and shown with mask. First, we have taken the brain MRI image, then we have taken the mask image, then we have segmented all this brain with this brain MRI image with this mask image, and we are segmented with the red color. Okay, so how we will perform this task? We will first create this particular data with some data frame. Okay, so those values which are not in a proper manner, we have to drop those values. So right here, what we are doing, we are using this brain underscore df variable, and inside this, whatever the image which is not in proper format, we have to drop that. Okay, so you have to provide right here the patient ID, and then brain underscore df underscore train, this particular folder, how much images are present, what is the size of that images, that will be shown right here. So you can see right here how much images are there. 3,929 images are there with the size of 3. Now, after this, what we have to do, we have to find out what is the memory uses of this particular data. And then we have to use this particular data for the training and testing. Okay, so we have to divide this data into train and test folder. Okay, so for the train and test split, what we are using right here, we are using this particular variable name, and we are defining test size is 0.15. So testing, 15% of images will go under this testing phase, and 85% of images will go under training phase. So training images are 85 and test images are 15%. Okay. Now we are using TensorFlow. Generally, this TensorFlow is used for parallel processing if your computer or system is containing GPUs. So you can install TensorFlow GPU and it will process all these images very fastly. Those who are not having this GPU capability, then you can install simple TensorFlow inside your system. But I have given you segmentation environment, no need to install any package over there. All the dependencies are already available over there. Just you have to execute this file as it is. Okay. Then you have to import the Keras. Keras is a library where all the layers which you need to import, all these layers are available inside this Keras package. Okay. Then we are using pre-processing. So pre-processing is another library where you have to use some pre-processing technique for that images. So you will use this pre-processing technique and then you can apply this particular function, which is image. Then what we are using from this, we are using image data generator. So from this TensorFlow, you are importing Keras model, then we are importing pre-processing, then we are importing image model, then we have to select this image data generator. So with the help of this image data generator, what we can do right here, we will rescale. Why we are rescaling right here? If your image is not in a proper scale, so that will create a problem. In convolution neural network, when you perform convolution, each and every image should be of the same size. So that's why we need to perform this rescale operation. And we are using this one with a value of 255, we will divide it. And then we are using validation split. So 15% data I am taking for the validation purpose also. Okay, from 85, I am taking 15% for the validation. Then we are using data generator and we are processing this data. And what we are doing right here, we are using the train model with a directory, this backslash, and we are passing this path of the image. Then we are creating this training. Batch size we are taking as 16. Shuffle we are using as true. And after this, you can see class model categorical, and target size is 256 by 256. So final output of the image is 255 by 255. Okay. So if you want to decrease this batch size, you can decrease, but it will take much more longer time to execute. If your system is with the low RAM, then it is recommended lower down this particular size. Otherwise, your system will hang and it will not work. Now, what we have to do after this, we have to use the valid generator. And here also, we have to define the different training options So we are first using this training, and we are training this mask type of images, and we are setting to the validation. And similarly, we are using the batch size right here as 16. Shuffle is true. So why we are using shuffle? Shuffle means we have to take the data in randomized format. Okay, initially you will start from 0. In next time you will start from any random value. Let's suppose that random value is 10. So you can pick the first image from 10 position. Okay. Then categorical class model we have select, and final size we have selected as 256 by 256. Then what we are doing, we are creating a data generator, and that will give the final output. Okay. So you can see right here, similar operation we are using for the test also. Initially we have selected okay, so initially what we have done, we have selected this training part. Next part we are using the testing. Okay, so similar thing, we are using this test generator, and after this 2 classes are created. First is train 1, and 2 folders are created, train and test. Okay, and one another folder, that is validation. So we have to perform all these operations on these folders. So till this point we have created only the data. We have not trained the model. What we have done, we have taken the data, we have selected the data, we have removed the unwanted images. Then we have created train and test and validation folder. Then we have defined the training parameter. Okay, after this, we have to define the model for training. So what we are doing, we are using TensorFlow. From this TensorFlow, we are importing the Keras, and from Keras, we are taking the layers. And what type of layers we are taking? We are using dense layer, then we are using dropout, convolution, 2-dimensional layer. We are using flatten layer. I am using average pooling, 2-dimensional. I am using then batch normalization. So all these layers are already defined inside the Keras. Okay. So we need not to define these layers. These are already defined. We have to just import these layers from the Keras. Okay. After that, what we are doing, we are using similar Keras model, and from that model, we are extracting the sequential. Why we are using sequential? Sequential is used right here. It will perform all the operation in sequential manner. First, it will perform convolution. Then it will perform all the operation related to convolution like stride, pooling. Then you will get the final output. Then you will get the maximum output from that. Okay. So sequential operation will be performed with the help of this model. After that, what we are using optimizer. I have told you Adam is the best optimizer. So right here, I'm using Adam. After that, we are using the transfer learning. Why we are using transfer learning? We have limited images and we are using deep learning. Let's take an example. If we will take only, if we want to take exam for our student, and we have to give 10 questions in the final exam. And throughout the semester, we taught only 10 questions to those students. So what is the output? They will learn everything. So similar thing is going to happen right here. If your images are less, this deep convolution neural network will learn everything and it will give you the 100% accuracy. But in real time, if we change, let's suppose that we have taught only 10 questions in throughout the semester, but in the final exam, outside examiner set the exam and he have given different questions to the student. Now, what is the result? They will get 0. So similar thing will happen right here. If your data is not proper, then you will not get the correct result in a real time. So you have to use the existing data first, use the existing data, then you have to retrain your data over that. Then you will get good accuracy. Okay, so right here we are importing this ResNet 50. So already all the images related to this type of problem, they have trained the model and they place this model inside this ResNet 50, and we are importing this model. Okay. After this, we are using this transfer knowledge weights, and we are getting ImageNet, and the info size of this ImageNet is 256 by 256 by 3. So what does this 3 means? 3 means 3 channels. Our image is in color format. So color format means red, green, and blue. So these 3 channels are present inside the image. What does this 255 means? This is the length and width of our image. Okay, so we have to select our image in 256 by 256 with a 3 channel. Okay, and what weight we are setting right here for ImageNet, we use this inclusive top as a false, and we are using image size as this one. Okay, so ImageNet will be present in according to this particular image size. So you have to create your data according to this size. Okay, now you can see the model summary right here. So what is present inside this ResNet 50? You can say input layer is there, 0 padding, convolution 2D, batch normalization, activation, 0 padding, max pooling, and similar layers will be added again and again. Okay, so this model will contain how much layers right here? ResNet 50 means 50 layers are present inside this particular model. Okay, so you can see this summary right here. Then we have to create the model. Firstly, sequential, this for this ResNet 50, similar input parameter we have to give. Then we have to give the input layer. First, we have to call the sequential model. Why we are calling this sequential model? Because we have to execute our convolution neural network, then we have to execute transfer learning operation, pooling operation, then we have to perform this fully connected operations, then we finally get the classification. So all these steps need to be performed in sequential manner. That's why we call this sequential model. After this, we are using convolution 2D operation. In this, we are taking the filter size of 3. I have told you in the previous slide, right here, you can see this kernel, which I have explained right here. I have taken 3 cross 3 kernel. So similar kernel I have to take right here. So kernel size, I have taken 3, filter size 3. Right here in this example, I have taken filters size is 1. Okay, I have not taken 3 filter. So in our program, we are taking 3 filters. So right here, I'm getting only 1 output. But in case of 3 filter, you will get 3 output. Okay, from these 3 output, you have to take the best one. Okay, so right here, we are taking 3 filter. Then we are defining the kernel size 3 cross 3. So you can see in this image, the kernel is 3. Length is 3, width is 3. So 3 cross 3 size of this kernel is present. Okay. Now the padding is same. Same means if something is less, then automatically it will add the padding. Then activation is ReLU. I have explained a ReLU operation to you. Okay. So ReLU operation you will see right here. Okay, this is the ReLU operation. So whenever your value is below 0 level, you will get 0 result. And when it is increasing from 0 to 1, you will get 1 output. Okay, so this is the ReLU operation you need to perform right here. Then the shape of the image, you know, in ImageNet 256 by 256 with color channel 3. Then we will add the base model, average pooling we have to give, flattening we have to provide. Okay, then batch normalization. Then dense layer, we have to give activation function ReLU, dropout. So these steps need to be performed in sequential manner. and you have to build the model. And you will see our model is built right here, like this: convolution 2D, ResNet, okay? Then average pooling, flatten, batch normalization, dense, dropout, dense, and you can say how much total parameter we have, okay? So much total parameters, how much training parameter, non-training parameters. So after this, what we have to do, we have to save the model. Let's suppose that in between, if light is gone and your system will switch off, what you will do? So let's suppose that our model is trained for 12 hours and suddenly light is gone. And what you will do? You have to store the values or store the maximum achievable output into the location, okay? So we are saving the model inside the given folder, okay? So whenever we will achieve best suitable result, those suitable result will be stored with the help of this HDF5 file, okay? The extension of this is .hdf5, okay? So everything that is to be executed with best possible output, that will be stored under this particular file, okay? Now checkpoint will be created and your model training. I have used comment option right here. Why I have given comment option? Because I have trained this model for 8 to 10 hours in the evening, okay? So if you train this model right now, it will take 8 to 10 hours, okay? So after this, what we have done, whatever the maximum achievable or maximum output or maximum best possible output that is stored inside this particular path, I am extracting that particular path inside this model. And I am evaluating this, okay? So what is the output of this particular model? So you can see right here how much I am getting the by predicted output, okay? So you will get all these values, and right here, you can see the confusion matrix. How much true values are there, how much false values are there, and what is the true positive and what is the true negative. So you can see this is 0, this is 0. So this means false. This is 1 and this is 1. Okay, so you can take 0, 1, 0, 1. So this 0, 0, so this is a true class. This 1, this is true class. 0 means there is a no tumor. 1 means there is a tumor. So 136 images are identified correctly with a tumor, and 386 images are extracted with a no tumor correctly, whereas 20 images are classified not correctly for this, and 48 images are not identified correctly. Okay, so this is a confusion matrix, and you will see the output for the precision recall and F1 and final output right here. So what you will do, you can take this data and perform different operation, increase or change the transfer learning model, and you can create a good research paper from this. And you will get right here what is the precision, recall, F1 and sport value, and what is the accuracy of the model. If you increase the training size, okay, and the training time, you will get the best accuracy. Right now, this F score is 0.88, okay. So in this manner, you will get the output. Time is over right now. So you can see these images are correctly classified right here. Segmentation part is not completed in this session, but how you have to detect the tumor, we have completed this part. So next part is the segmentation of brain tumor part. So we will not cover this segmentation part right now. It will take again 2 hours. So Thank you very much. If you understood, please say something. Have you understood or not?
Sir, the flow is very much clear. The more clarity we shall get after receiving your video and we'll practice it hands-on. Thank you.
Thank you, sir.
Flow is very much clear, sir.
Any other participant, if you have any question, we are happy to answer you. You can see right here, I am running this code and it is showing me the accuracy 70% accuracy.